Part 1. It gives us a quadratic expression, and it tells us to show that that's got to be greater than 0 for all real values of x. So the best way to do this is to do something called completing the square. So we complete the square. Now what this means is we start off by looking at this first part here, this x squared minus 8. Now what you have to realise is that if we halve the minus 8, so it's minus 4, and then square it, what we're going to get x squared, and then we're going to get minus 4x minus another 4x, so we're going to get minus 8x, and then we're going to get minus 4 times minus 4, which is plus 16. So by using x minus 4 all squared, we can actually get our x squared minus 8x. However, we also get an extra 16 with it, which we might not want. So what we have to do is we say the x squared minus 8x is the same as x minus 4 squared, and then what we have to do is take away the 16 that the 4 squared gives us. But then we've got to remember to add on the 17. Okay, when we do that, we find that the expression equals x minus 4 squared plus 1. So now what we have to do is we have to show that x minus 4 squared plus 1 is greater than 0. Well, we know that x minus 4 all squared, we know that's got to be, it's a square number, so it's got to be either bigger than, or I suppose if x equals 4, it could actually be equal to 0. But if x is not equal to 4, if x is any other number, whether it be a negative number or a positive number, as long as it's not equal to 4, when we square it, when we take away 4 and square it, we're always going to get a positive value. So x minus 4 all squared, and any number all squared, or any expression all squared, has got to be greater than or equal to 0. So if x minus 4 squared is greater than or equal to 0, and we add 1, it must be the case that x minus 4 squared add 1 must be greater than 0. But we know that x minus 4 squared plus 1 is actually the same as the expression they give us. So we've proved it greater than 0 as required. Done. Okay. Now let's just have a look. Part 2. If I add 3 to a number and square the sum, the result is greater than the square of the original number. And we've got to give reasons to say whether that statement's always true, sometimes true, or never true. So I'll write it out algebraically. It told us that we add 3 to a number. So if we call the number, so let number equal n. So if we add 3, we get n plus 3, and then we square it, we get n plus 3 squared. And it's telling us that the result, when we do that, is greater than the square of the original number, which is n squared. So what we've got to do is think about whether we can say that it's always true that n plus 3 all squared is bigger than n squared. Well, all we have to do is just try it out with different numbers. So if we say that n equals minus 3, so if n equals minus 3, then if n equals minus 3, then n plus 3 squared is going to be 0 squared, which is equal to 0. But minus 3 squared is going to be 9. So in that case, n plus 3 squared is not greater than n squared. So our statement is certainly not true when n is minus 3. So can we say that the statement is never true? Well, if we can find another example where it is true, then we can't say that it's never true, and the answer must be that it's sometimes true. So let's just try n equals 1. Okay, and if n equals 1, we're going to have 1 plus 3, which is 4. 4 squared equals 16, and 1 squared, of course, is 1. So in that case, n plus 3 squared is in fact greater than n squared. Okay, so what we can do is, using those two examples, we can say that statement is sometimes, hence statement is sometimes true.